welcome to In 5 Minutes. In this particular video clip, we will discuss another circuit which is used for the generation of double sideband suppressed carrier signal. It is called balanced ring modulator. It is sometimes also called double balanced ring modulator because in the previous circuit of diode balanced modulator, we were able to suppress the carrier signal. So we balanced off the carrier signal. The output was only in the form of two sidebands. But if you remember, there was one more extra component which was not required on the output side. This component was in the form of modulating signal. To remove modulating signal, we had to use bandpass filter on the output side. Now, ideally, this modulating signal should also not have come on the output side because when I want my output to be double sideband suppressed carrier, I want only the two sidebands and no third signal. So let us see how to get rid of the modulating signal also along with the carrier signal at the output side. So for which we have the circuit which is called balanced ring modulator. We call it double balanced modulator because it will remove the carrier signal as well as the modulating signal. My output will only consist of the two side bands. Let us look at the circuit diagram and we'll discuss its working in parts. It consists of four diodes connected in a very specific manner. You can see two diodes D1 and D2 are connected in the upper and the lower branch from input towards the output side. So pointing towards the output side. And the two diodes connected in diagonal branches are pointing towards the input side. Right? This kind of connection will give us one very specific type of operation when we discuss the working. Before that, let us understand why it is called ring modulator. It is called ring modulator for a simple reason that if you flip this diode D2, if you just flip it, you will see that you will have a ring of four diodes forms. This is my diode D1. You will have diode D4 coming here. You will have third diode which is D2. I have flipped this diode D2 and you have the fourth diode present on the other side. This is nothing but my D3. So it forms a ring of four diodes and that's the reason it is called ring modulator. On the input side, from the left hand side input, we are applying modulating signal through a center tap transformer again. The carrier signal is applied through the center tap terminals of both the transformers. Let us say the modulating signal input has the peak amplitude of Vn and the carrier input signal has the peak amplitude of Vc. In that case, we make one assumption which is required for the proper functioning of the circuit. The assumption is that the carrier amplitude Vc has to be very large compared to the modulating amplitude Vm. And because of this condition, let us try to understand what effect we will have on the working of the circuit.